In this lecture, we will look at the shapes that distributions assume based on their values for the measures of central tendency. We will also describe the basic characteristics of a line graph. There are two symmetrical distributions of note. First, the normal distribution. The normal distribution, sometimes referred to as a bell curve, is extremely important in statistics, and we'll spend a great deal of this course getting to know the normal distribution inside and out. Another way to have a frequency distribution result in a symmetrical distribution is if all the scores on a measure occur the same number of times. This is called a rectangular distribution. While somewhat uncommon, a data set for a rectangular distribution may look like scores of 3, 4, 5, 6, and 7 all occurring 3 times. Remember, when you're looking at these graphs, there is an implied label for the y-axis of frequency, and the x-axis is always some type of continuous, that is interval or ratio level, quantitative variable. There are two major types of skewed distributions. These graphs are called skewed because they are not symmetrical. In Chapter 3, we'll learn what makes certain distributions asymmetrical in terms of their measures of central tendency, that is, their mean, median, and mode. At this stage, though, we just want to ensure everyone can recognize the two types of skew by visually examining their shapes. A positively skewed or right-skewed distribution has a narrow point, called the tail, to the right of the distribution. Remember, these graphs are frequency distributions. Thus, if the tail represents the shorter bars in a histogram, there are fewer scores on the right. Also remember, the horizontal axis is like a number line, on which high scores are towards the right, or the positive side of the number line, and low scores are towards the left, towards the negative side of a number line. Always look at the tail to determine the distribution skew, not the hump. The tallest part of the distribution, that is, the hump, is where the most scores are recorded because the height indicates the frequency of each score. Thus, the higher the hump, the more scores in that range. So, in a positively skewed distribution, the tail is to the right, and it actually has a predominance of lower scores, while a negatively skewed distribution, also known as a left skewed or skewed to the left distribution, has a tail to the left, and that means a greater proportion of higher scores. Speaking of humps, there is one more type of distribution Spatz introduces in Chapter 2, a bimodal distribution. When two separate ranges of scores have high frequency, the distribution would end up having two humps to correspond to those high occurring score ranges. Thus, we call the distribution bimodal because the most frequently occurring score is defined as the data's mode. Having two modes makes a distribution bi for two and modal for modes. Finally, Spatz introduces line graphs in Chapter 2 as a means to show the relationship between two variables. The dots on a line graph represent a pair of data on the x and y axes. Both of these variables must be quantitative and continuous, that is, interval or ratio level. Figure 2.9 is from your text on page 36, and Spatz states, Figure 2.9 is an example of a line graph. It shows the serial position effect. If you practice an ordered list of words until you can repeat it without error, you'll find that you make the most errors on the words just past the middle. The serial position effect applies to any sequence of material that is learned in order. Taking a look at this graph, I can see that just past the midpoint, or the middle of the serial position list, is when the most errors occur. This graph, therefore, can show me in one image what I would have to look at a whole bunch of data as numbers to find myself. Let's practice what we've learned about distribution shapes by working through exercise 2.15 from page 38 in Spatz 2011. A. The age of all people alive today. This distribution is likely to be positively skewed because the world's population is dominated by younger people. While there are certainly loads of older folks, these numbers are less large because of death from old age, accidents, illness, or other circumstances whose probability increases with the passage of time. With predominance of people of lower age and relatively fewer older people, the hump of this distribution would be on the left and the tail would lie on the right, making this a positive or right-skewed distribution. B. The age and months of all first graders is likely symmetrical. Most first graders will be around the same age in years, but if you look at the months, they're going to be also somewhat similar simply because of the way the birthdays lie in a year. There will be some first graders with older months and younger months of birth, but all in all, it should end up fairly symmetrical and perhaps even rectangular-ish. C. The number of children in families is another example of a positive skew. Most families will have lower numbers of children. Of course, there are always a few families that buck the norm. For example, have you seen that reality TV show on the Learning Channel, 19 Kids and Counting? I mean, really? So anyhow, there will be a few occurrences of large families, making a narrow tail at the right side, because more kids in the family would mean recording data on the right, less kids on the left. If the predominance is for less kids, then the hump will be on the left, the tail on the right, and this is another positively skewed distribution. D. The wages in a large manufacturing plant are likely positively skewed because the majority of employees are workers, making considerably less money usually than the fewer number of management, which would have higher salaries. So again, we have a case of lots of low scores, that's low wages in this example, and a few high scores, high wages, making the overall distribution skewed to the right because the tail would be on the right-hand side. E. A distribution of the ages of every person who died last year is a pretty morbid example, but it is one that gives us a negatively skewed distribution, because the majority of deaths were likely due to old age and associated factors with aging. There will, of course, still be considerable numbers of deaths of young people, but likely there are much less than the total number of deaths from older people. With the hump on the right and the tail on the left, this is an example of a negatively skewed distribution. Finally, shoe size is a good example of a symmetrical distribution. Just like heights, male and female shoe sizes vary somewhat predictably, with the vast majority of people having fairly similarly sized feet. Less numbers of people have very large or very small feet.